Hello everyone, welcome back to my channel. So till now we have discovered what are loops in Java, what are conditional statements. We have discovered different kinds of loops like for loop, while loop, for each loop, do while loop as well. And in conditional statement we have completed else, if else, and with multiple if as well. So else if and this switch statements, correct? So we have discovered this much of the looping and the conditional statement till now. So now today our topic is break and continue. And as I have promised that we are also going to learn about recursion today. So first we'll start with what are break and continue statement, how we can use it, what are the need of them, and what is the syntax of writing the break and continue statement in Java. So let's get started with this. So for example, if I want you to run a loop from 1 to 20, how you will write the syntax for this loop? You will say int I is equals to 1, I less than or equals to 20, and I plus plus. This is the syntax for loop, and you will print system.out.println and you will print I, correct? So this loop will be printing numbers from 1 to 20, correct? 1 2 3 4 5 6 7 and so on up till the number 20. But now what if I ask you, all right, you have to print all the numbers from 1 to 20 but just skip the number 4 or just skip the number 7. How can you do that? There is other alternative, or okay, let me just change the question. How all right, so this is your n, you have to run a loop from 1 to 20. I am changing the question that you have to stop the loop once the 7 is found or once the I reaches the number 7. So how you will do? What do I mean is you have to print 1 2 3 4 5 6, okay, and as soon as it reaches 7 your loop should stop. So you have to do only this much of task, but your looping condition is this, correct? All right, so how can you achieve this? Is there any way to achieve this? Like I want to break my loop as soon as it reaches, as soon as my I becomes 7, as soon as my I is equals to 7, I have to break my loop. So yes, you can get an idea that I have to use if condition, correct? So the condition is if I is equals to 7, I have to break my loop. So what is the syntax for breaking our loop? So if I say you can use the break statement, and if you try to run this code, this will work as we has discussed, because as I said that if you want to break a loop, you can use a break statement. All right, so as soon as I is equals to 7, our loop gets terminated. So what will be the output for this statement? So it will print 1 2 3 4 5 and 6. And what if I write print over this, like over here before this line? So what will happen? It will print 1 2 3 4 5 6 and it will print 7 as well. Then it will reach to this line and it will say, hey, okay, if I is equals to 7, okay, I is 7, it is true, you have to break the loop. So it will print 7 because you have written the print statement before this, correct? No, I have asked you that you have to terminate this loop, but your condition is like you have to run the loop up till 20 only. The condition you cannot change. All right, I can give any number in between 20. Okay, so you don't have to change it again and again. You are telling me that you change the condition to 7, but what I said that you have to run a loop for this 1 to 20, because in real time examples you might get an idea, or you might have this approach, or you might need this kind of thing to break a loop, and we'll see why do we need that. We'll see a real time example, don't worry about this. All right, so let me write a code for this and then it will be much clear. to you all. So if I say int I is equals to 0, I less than or equals to 20, okay, let me make it 1, and I plus plus. And if I say if, as soon as I becomes, or if I is equals to 7, you have to break the loop. Am I right? All right. And then else you have to print this. Correct. So what you have to print? You have to print I. Or let me just remove this ln. And now if I try to run this, what will happen? What will be the output? The output will be 1, 2, 3, 4, 5 and 6. Correct? Yes. So this is the output that we have discussed till now. So what if I declare the printing statement above this line? Or what if I place it at the line number 90? Let's see the output. The output comes out to be 1, 2, 3, 4, 5, 6, 7. So 7 is getting included. So what happens over here? I is 1, condition is met, print I. 1 is printed, check the condition. Condition is not true. Again loop. But now I becomes 2. I becomes 2, you have to print 2. Check the condition. Is the condition true? No. Again false. Again loop. But increment I. So now I become 3. You have to print 3. Is the condition true? No. Increment I. Now I become 4. Check the condition. Yes, it is true. Go inside the loop. Print I. Printed 4. Check the condition. Condition again false. Increment I. I becomes 5. Condition is true. Print 5. And again this condition is not false. Increment I. 6. Condition is true. Print 6. Condition is false. Now I becomes 7. You have to print 7. Is the condition true? Yes. Now the condition is true. So the break statement will break the nearest loop to it. So this is the nearest loop, or the loop within if is located. Am I right? So if is located inside this loop, so it will break this loop. All right. So I hope it is clear till now. All right. Okay. So now let me take a real-time example for this, and we'll use a break statement in a real-time example. So let me declare a array, and I'm having some elements 4, 67, 87, 89, 43, 6, 2, 1. Right. Take care of this. Yes. This is an array. Now I want you to search n inside the array. So for now n is let's say 89. Yes. So our n is n. What we have to do is we have to search whether n is present inside the array or not. Am I right? So what we'll do, we'll run a loop. We know how to print or how to access each and every element of an array. So we can use for each loop as well. Am I right? Yes. So for now we'll use just traditional for loop. We are going to start it with 0 because the index is always from 0. I plus plus. All right. Now what is the need? See, what we previously did was if array I is equals to n, then you have to print system.out.println found. Am I right? All right. Now yes, what happens now? It will go I is equals to 0, condition is true, arrays ith element, that is 0th element, what is the array's 0th element? It is 4. So is 4 equals to n? No, condition is false. It will move to the next element because I gets incremented. So it will check array I. I is 1 for now. So is 67 equals to n? N is 89, correct? No. Again go ahead. Is 87 equals to 89? No. Again go ahead. Is 89 equals to 89? Print found. Then is 43 equals to n? No. Is 6? So what happens? You already found your number, but it is still running for these numbers. Am I right? So is there any need? Because you have successfully found your number, then there is no need of going further, correct? So we don't have to go further if we have done our task. There is no need and there is no sense of going up till the last element. So what we can do is, if we have found, if the condition is met, we can print found and we can break our loop. Am I right? So over here, if I say break, will this work? Definitely, correct? See, it says found. Now you might need a proof, correct? So what if I don't write this and I'll just say system.out.println and I'll just print the current element. All right, can you see how this code drives? It first print the 0th element, 87th element. It says found. All right, it is not here. Yes, 0th element, first element 87, and then it says found and it prints the 89, and then 43, 6, 2 and 1, which says that this loop is running for each and every element. Now what if I include break over here? Let us try that. Can you see the output? See, as soon as it founds the element over here, it says found and breaks the loop. The loop now gets terminated. So not even the 89 is getting printed because we have break the loop at the line number 96. So as soon as it reaches this line, as soon as the compiler reads that, hey, I want to break this loop, which means it will terminate the execution at that time only. So it won't get executed for the each and every element. So I hope now you have a better understanding that how you can use the break statements, correct? All right, great. So now we have an understanding that how we can use the break statement, and this was a kind of problem that where we were searching an element inside the array, and we have optimized it because we know that if I have found the element at the 0th index, then there is no sense of going ahead because there might be 100 of element after our n element, correct? So there is no sense for traversing to each and every element. So that's the reason why we can use break, so that we reduce the time for the execution. All right, so now let's proceed further. Now let me introduce you with continue statements. The first problem that we discussed, I want to print 1 to 20, okay, but I have to skip number 7. How you can do this is, so what we will do is, for printing number 1, I less than or equals to 20, I plus plus, what we'll do? We'll do print I, correct? But for checking whether the number is 7, because we have to skip that number, am I right? If n is equals to, sorry, I is equals to n, that is our number 7. How you can do this? If you write break, it will only run till 6, or I can say it will run till 7, but it won't print 7, correct? And it won't print other numbers as well. So you cannot use break over here. So what you can use is, you can use continue. So how continue works is, let me write the code for this and then you will get a better understanding. Yes, so system.out. For loop, correct? int I is equals to 1, I less than or equals to 20, I plus plus. Alright, and then see, the other alternative is checking by using if and else, but for now we are focusing on continuous statements, correct? So if I is equals to 7, let's say, we have to break this, otherwise you have to do the normal task, it is print I. Now let me run this program. Can you see 1, 2, 3, 4, 5, 6 and 8, 9, 10, 11, 12 up till 20. So the reason for this is how this works. I is 1, condition is met, this is not met, you have to print I. Great. For 2 it works the same way, 3 same way, 4 same way, 5 same way and 6 same way. Now I become 7. I become 7, condition is met, go inside the loop. Over here this condition is satisfied. As soon as this condition is satisfied, the interpreter encounter a statement saying that hey, you have to continue with the flow or you have to continue with the other iteration. So as soon as it encounter this statement, as soon as the interpreter reads continue, it will directly head to this point by incrementing the value of I. Over here it hits this point and it will say okay, you have to increment I. Now I becomes 8 and execution again get started as the way it was getting executed, correct? So now the condition is false, it prints 8. So for 7 it never reached this line, so that's the reason why it didn't print 7, correct? All right, so I hope you are understanding that how continue and break is useful. So if you want to skip few things, so not over here it is just working for 7, but what if you want multiples of 7, am I right? What if you want to skip for multiple of 7? So how you can do is, you know modulus, correct? So if any number modulus of 7 returns 0, which means it is a multiple of 7. So for let's say 14 mod 7, which will give remainder as 0, which means 14 is a multiple of 7, correct? If I say 22 mod 7, it will return 1 mod, which means it is not a multiple of 7, so this condition won't get satisfied. So in this execution what we are doing, we are skipping the multiple of 7s. So let me run this. See, what are the multiple of 7 between 1 and 20? They are 7 and 14, correct? So 1, 2, 3, 4, 5, 6, 7. 7 missed, correct? Now let's go down. Yes. So after 12, 13, we have missed 14 again, and it is working as we expected. So this is how you can use the switch statements and also the break statements. Now you are asking that how to print the index instead of found. You want to print the index where I is found. All right, no worries. But see, this is the logic building process that you can do it, and I'm damn sure that you can do it in a right way. So what will happen? You have to print the index of I. So you can just simply say I, correct? All right, let me just comment this. Yes, if I said this, can you see the output comes out to be 3, which means the index is 3. Is it correct? 0, 1, 2, 3. So 89 is at the third index and it is giving us the correct output, correct? So yes, this is the logic building process. If you give, or I can say that if you practice some of the questions, it will be very handy for you. So don't worry about this. First we need to understand the concept that how you can use this, how it can be useful. You should be aware that there are things that can terminate your loop, that can skip particular values. So as soon as it encounters the continue statement, is always comes over here. So let there be 100 lines of code after this line. As soon as it encounter continue, it directly moves to the next iteration, and as soon as it encounters the break, it will break at that time, at that moment immediately, correct? Let there be 100 lines after that. Yes. So this is how break and continue can be useful. Yes. All right. So now there can be nested loops as well. So for example, I have loop within a loop. So my I is equals to 0, I less than let's say 5 only. So it will run for 0, 1, 2, 3 and 4, I plus plus. Okay, so over here what happens? Okay, the variables overlapping. Yes. Now how many times this thing is going to get repeated? Okay, so over here I'm just making slight changes. Instead of this, I'm making it like this, and I'm not using any break statement, because now for this moment of time we are just learning how nested loop works. So if I say system.out.println I plus j, now just see the output. Let me just find this. Yes, so can you see the output? I'll write the code over here, do not worry. So our first loop was for int I is equals to 0. It was running up till 5, less than 5, and the inner loop was also following the same syntax, or it was j, sorry, and it was I. And we are printing system.out.println I plus j. So how this will work? J is equals to 0, correct? J is equals to 0, j less than or equals to 5, condition is met. You have to run this loop. Now this loop will run until and unless it is get terminated, correct? It gets terminated. So over here I is equals to 0, condition is met, you have to print I. So I is 0, j is again 0. Now this loop is not terminated yet, so it will again go over here, I gets incremented, I becomes 1, condition is met, you have to print I, and j is still 0 because this has run only one time and this is still in execution. Am I right? So now it will again move over here. It will only terminate if the condition gets false over here. So now I becomes 2, condition is met, 2, 0. J is still 0 because we haven't reached yet over here. So now again there is no false condition, so again it goes over here, I becomes 3, condition is met, prints 3, 0. Then I become 4, prints 4, 0. Then I becomes 5, condition is not satisfied, correct? So this loop gets terminated, and if the loop gets terminated, which means it comes over here, and after that there is no any other instructions, which means that this loop has completed its first iteration, correct? Now j becomes 1. So now j becomes 1, it will again go inside this and it will work the same way it previously worked. Okay, so now what will happen? Again the same stuff, but I is 0 but j is 1, then I is 1, j is still 1, I is 2, j is still 1, 3, 1, 4, 1. Now I become 5, loop gets terminated, it again comes over here. Yes, this might be confusing for now, but if you give it a time, if you go take pen and paper and just practice this now, how the execution flow is working, you will be getting a better idea. So don't worry about this, it is quite easy, just you need to understand by giving it some time. So yes, this needs time, but yes, you will be learning it easily. So now the j becomes 2. Then again the same process, 0 to 1 to 3 to 4 to 2 to, yes, now the j becomes 3. So and so on until and unless this condition is false. So now how many times? Now my question is, how many times or how many values will be printed? Can you now give me an idea? We have executed the loop the way we got the output. Am I right? So how many times this loop will run? See, this outer loop will run for 5 times and the inner loop will run for 5 times per iteration of this. Alright, so for this runs for first time, second time, third time, fourth time, fifth time, and the inner loop runs for 5 times. So how many values we are going to get? 5 5s are 25. Am I right? Because this loop will run for 5 times, and for each time the inner loop will be running 5 times. So inner loop is the one who is printing the values. That's the reason why we'll be having the 25 outputs. So do you have any doubts? Yes. Alright, so if you have any doubts, you can ask me. So now the reason why I took this nested loop topic now, because we have to learn labels. So what are labels? See, previously we did that we found 7 and we break this loop using the break statement. What if there is a need of breaking the outer loop? Because as I said, break statement will always break the loop closest to it or loop in which break is enclosed. Correct. So if I use break statement at the line number 89, then it will terminate the inner loop, not this loop. But what if you have a need in program in future that you have to terminate the loop at some point? So how you can do it? So here comes the concept of label. Okay, so if I say, if let's say I is equals to 3, I have to break the loop. Now let me explain the execution for this. Let me just reduce these numbers. Yes, so how many times, if there is no break statement over here, how many times this loop would have run? 3 for the outer loop, and for each iteration the inner loop would have run 5 times, so it will run for 15 times. But now I am including the break statement at I is equals to 3. So how many times the inner loop will run? It will run for 0, it will run for 2, sorry, it will run for 1, it will run for 2, and it will run for 3, but as soon as it reaches over here it won't print the values. Correct. So we'll get 3 outputs, 3 values inside the console per iteration of the inner outer loop. Correct. So 3 3 3, so we'll get altogether 9 outputs. So let's see whether we get 9 or more. Yes, so we get 9 outputs. Correct. So the reason for this is, you might have already guessed that for int I is equals to 0, I less than 5, or let us make it 3, I plus plus, if you say for int j is equals to 0, let this be 10 as well. But what will happen? Your if statement is the one who is terminating the condition. Correct. If j is equals to 3, then you have to break, or else you have to print j comma or j space I. Yes, correct. So now what will be the output? I is equals to 0 for now, j is equals to 0, j is not this, so we have to print 0 j, that is j, and 0. Correct. The next iteration, j become 1, condition is met, but this condition is not met, print this 1 0. J is now 2, then this condition is not met, print 2 0. Now j becomes 3, this condition is met, you have to break the closest loop or the loop in which if is enclosed. So an if is enclosed in this loop, so we are breaking this and we are going over here. So now I becomes 1, and the same thing happened for the first I1 and I2 as well. So I hope it is clear to you now. Do you have doubts? All right. So yes, but now the need for labels, as I said, we don't have to terminate my inner loop. I don't have to terminate my inner loop. I have to terminate my outer loop. As soon as I becomes 3, my outer loop should get terminated. So how I can do is, I can use labels. So I will say that I'll give this a label. So let me give a label as x. The label is x. Now I want to break the loop which is having the label x. So I will say break x. That's it. This is the label. Okay. So it will look, if I is equals to 3 and the condition is met, so it will look for a loop that is having a label x. So is there any loop? Yes, there is a loop, and it will terminate this loop. So now can you guess the output? Take your time. Let me change the code. Let me provide the label. And if you can do this without my explanation, then it's a great thing. So take your time, pause the video and try to get the output for this. Yes, you can go with the actual flow. Take pen and paper. Check. All right, j is equals to 0, I is equals to 0. Condition is met. This condition is met. This condition is not met. I have to print I, that is 0, and j, that is still 0. Go over here. I becomes 1. Condition is again not met. Print I and j, that is 0 still. I becomes 2 now. Condition is met. This condition is not met. Print I and j. I becomes 3 now. Check the condition. Condition is met. Is this condition met? Yes. You have to break a loop. Which loop you have to break? The loop with a label of x. Break this loop. You come over here. So how many output you get? You get only 3 outputs. Correct? So let me run this, and can you see? This is what we have discussed over here: 0 0 1 0 and 2 0. So that's what the output is. We have got only 3 outputs. So that's the reason why you can use the label. Can you see that the label terminates the outer loop? So it's up to you which loop you want to terminate. So yes, continue also work the same way. You can use label with continue as well. So now the question arises, whether can I use the labels with if or else? Correct? This is a valid question. Am I right? So let us try this. If let's say 67 greater than 7, break, else system.out.println hello, I am here. Can you see? We get an error. Cannot break cannot be used outside of a loop or switch. So yes, in switch we have already discussed that how break works. So now I hope you are getting a clear idea that how break works. Wherever break is there, it will terminate the execution for that particular block. That's it. Or I can say that for that particular loop. But it also works for the switch. Now can I use label over here? Will it work? It does, correct? So the reason for this, now you will ask me that why do I need a label, or why do I need a break statement in if else? Am I right? So the reason for this is, there might be a scenario, it is not much used, but then too you should be aware, like you can get this in MCQs. All right. Yes. So now there might be scenarios that you are having n number of instructions. So let's say 10 instructions. So yes. So you have 10 instructions in your if statement, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You want 10 of them to get executed, but if for a particular for a particular condition, if you want that only 5 of the execution should get executed and not the rest of them, or none of them, correct? So what you do is, you use a break statement. You can use, like it is not much being used, but then too you should be aware that you can use labels with this, correct? Yes. Now let's try with continue. Can I do continue? No, we get an error. Continue cannot be used outside of a loop. Let me remove the labels. Then too we are getting error. See what break does, what break was terminating our execution, and now what continue was doing, sorry, continue was taking us to what's the next iteration. So execution can be terminated for this block, it is valid example, but can we move to the next iteration? Is if a iterating loop? No, if it is not a loop, it is a conditional statement. If else are the thing that are going to run only once, so there is no other iterations, correct? So that's the reason why we don't have continue, or we cannot use continue in if else block. So just keep that thing in mind, and you can use break, continue in any loops, okay? For loop, while loop, do while loop. All right. So I hope now you got a better understanding that where do we use continue, break, and where we cannot, like in if else we cannot use the continue, and normal break cannot be used in if as well. So for using break in if else, we use the labels. So I hope it is clear to all of you, and if you have any doubts, you can ask me now in the chat box. All right. Yes. So now the next topic that we are going to learn is recursion. All right. So let us learn recursion. Okay. Yes. Just a second. Let me define a class. Recursion. Yes. Now let me write a main method. So what do you mean by recursion? Recursion means one method calling itself again. So if I am having a method, let's say public void recur. Now this method is calling itself again like this. So let me make it static so that we don't need an object for calling this. Can I call recur over here? Now can you guess what will happen? Yes. So see what will happen over here. JVM founds the main method. The first instruction is to call the recur method. Where is recur method? It is right over here. It will go inside it and it will say, hey, you have to call the recur method. Where is it? It is here. You again go inside it and it is saying that, hey, you have to call the recur method. You again come over here. Correct? So execution is never ending. You don't have any terminating statement. So it will again go infinitely recursive calls. Correct? So now let us run this. So now can you see the output? We get an error and the error is stack overflow error. So stack overflow error is an error that we get when we overflow our stack. So now what happens? What is stack? Don't worry about this again. But yes, then too we have an understanding between a stack and heap memory. Am I right? Yes. So now what happens in a stack? This method is called, but for completing its execution we have to reach this point. Am I right? How it will reach this point? By executing the instructions one by one. So the first instruction is saying that you have to go to a recur method. Where is it? Alright, it is over here. I have to go inside this method. It is saying that you have to again go inside this. So what happens? Recur. This is our first recur. Okay. After this, this calls the recur again, and this calls the recur again. So the first recur is yet not completed, because as soon as this gets complete, this will get complete, and then this will get complete. So it is still maintained inside the stack. So if you call it infinitely, we'll have the infinite number of recur functions or recur methods inside the stack, and we'll get a stack overflow error, because this is never getting terminated, because our interpreter is never reaching at this point. So that's the reason why we get an error. So terminating statement is one of the key point in terminating case is one of the key point in recursion. All right. Now first you will ask me that what is the need of recursion? So sometimes things might get complex. For now I cannot take you to that kind of problems directly, but then too you have to understand that later when you proceed with actual programming, when you do problem solvings, there might be scenarios which get complex in your normal loops. So you use recursion. So when you know that this part of task is getting again and again, I want to execute this again and again. Yeah, loop is a better idea, but then too sometime it might get complex. So for understanding, I'm just having a normal example that we have discovered till now. So we have learned about a problem of factorial. For finding a factorial, what we did? 5 into 4 into 3 into 2 into 1. What we did? We ran a loop from I is equals to n. We gave a condition I greater than or equals to 1 and I minus minus. We maintained a variable fact and we initialized it with 1. Am I right? And each time we did what? We did fact is equals to fact into I. Am I right? So this is how we did the factorial stuff. Now let me do it in a recursion way, a recursive way. Alright, so I'll declare a method called as fact. Okay, let me write it over here, and this method will return the factorial of our number. So I'll pass a number to it, number n. So what you have to return? You know that you have to always go n minus 1. See, if I say 5 into 4 into 3 into 2 into 1, if my n is 5, so what will be the statement? 5 into 4 into 3 into 1. So what is this? N into n minus 1, and then this is n minus 2, n minus 3, n minus 4, or I can say that n minus 1, which is this part, minus 1. Correct? and then this is nothing but n minus 1 minus 1 minus 1. So this is a kind of recursive problem that we can solve it in a recursive way. All right, so what happens over here, what I have to return? First thing you have to notice this, I am returning, you have to understand the basic trait for this problem. So what is the basic trait? If I do n into, I have to do just minus 1 again and again. So if I say, if I pass fact n minus 1, this won't be at odd, means this will not be clear at all for now, but once we go through the problem step by step, I hope it will be clear to all of you. So let me again explain this. So what is the basic trait over here is fact n minus 1. What it will do is, you have to return means you have to terminate by returning this value, correct? All right, so you are returning 5, let's say our n is 5, you are returning 5 into, again you are passing fact 4, correct? 5 minus 1 is 4, so this will return what? This will go over here, but now for n is, this is 4, so this will return what? 4 into fact 3, am I right? Definitely. Now this will return what? 3 into fact of 2. So this is how the execution will take place. But now the catch over here is, you cannot do this like this way. Now the reason for this means it is incomplete for now. Okay, just a second. Yes, so the code is incomplete. The reason, the first thing that we have discussed is the terminating case. When this code is getting terminated, otherwise we'll again have the infinite loop. This will go 5, 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, and till the infinity. Correct. So we have to add a infinity case. Oh, sorry, the terminating case. So what will be the terminating case for a factorial? We have to run it up till 1, correct? So we can have the terminating case like if n is equals to 1, or for the safer side we can also check for 0, because if the n is 0 we have to just directly return 1, am I right? Yes. So if n is equals to 1 or n is equals to 0, what we have to return? We have to return 1. Now this is the terminating case. Now how this code gets terminated, I'll write a code over here, we'll go step by step and then we'll understand it in a better way. So let me write the fact matter. So fact int n, the variable that we discussed, a terminating case if n is equals to 0 or I'm making things bit confusing so that you understand, or you give it a time to understand, because if we are just going through easy stuff, then it might be difficult in future. So we need to cover recursion as well, it is an important topic. So we have to return 0. All right, now yes, it is void, so I have to make it int. Now what we have to return, if it is not this, we have to return asterisk fact n minus 1. All right, now let me call this system.out.println. I have to catch the value thrown by fact and 5. What is the factorial of 5? It is 120. Will it give 120 to us? Let's check that. Sorry, here I need to return 1 na, for factorial 0. Yes, we get the output as 120. So now what is the, how do we get this 120? How we get the correct output? How this is working? These are the questions in your mind, correct? So now let's go through your questions. First question, how this works. actually the working of this, how it gets terminated, and how it returns the correct value. Because by looking at the code, I cannot assure you that it will always return the correct output, because we are confused that how it is working. Am I right? So let's discuss this. I am passing 5 come over here, n is equals to 5. Condition is not satisfied. You have to return. Let me make the stack now. So you have to return n, that is 5 into fact of 5 minus 1, that is 4. This will do what? Or let me just delete this. A simple way. We have to return 5 into fact of 4. What this will return? You are now again over here, but now for this part, okay, see, this execution is still not completed, correct? It has just redirected it to itself by some different value. So now 4 comes over here for a new iteration. This iteration has not completed yet. For completing this iteration, you have to complete the further iterations. So now this iteration says that you have to return 4, that is n into, because this condition is not met, n into, again you have to call this recursively, that is 4 minus 1, that is 3. Again move to this part. For this part, n is equals to 3. Condition is not satisfied. You have to return 3 into fact of 2. Alright, what this will do? It will come over here. N is 2 for now. For this part. For this it is 3. For this it was 4. And for the first iteration it was 5. And it is still 5 for that. But now we have called this method how many times? The first time, the second time, the third time, now the fourth time. Am I right? Yes. So now this will return what? N is equals to 2. Condition is again not satisfied. You have to return 2 into fact of 1. N becomes, or n is 1 for the next iteration. Is the condition is true? Yes, the condition is true. So this will return what? This will return us the value 1. Correct? So as soon as this return once, this becomes 2. 2 into 1 is 2. So this method will return us 2. 3 into 2, 6. This method will return us 6. 4 into 6, 4 into 6, 24. So this will return us 24. 24 into 5, 120. And that's how we get the output. So I hope that you get a better understanding of recursion. Let me explain it again. So n is equals to 5. You have to return 5 into fact of 4, then 4 into fact of 3, then 3 into fact of 2, and then 2 into fact of 1, and then this will return us 1. Correct? So if you multiply these things, we get the output as 5 into 4 into 3 into 2 into 1. But this is what we visualize. But what happens behind the scene? This is going to return as 1. So 1 come over here, because it has to perform the computation. It has to return an int value. This returns an int value, and the int value is 1. So 1 comes over here, it is 2. This returns 2. 2 comes over here, it is 6. So this return 6. 6 comes over here, it is 24. So 24 comes over here, and now at the last moment we have 5 into 24, and this is what we are actually returning. So we are returning 120. So I hope it is clear to everyone, and you know that why do we get a stack overflow error. So now you know that what is the need of a terminating case in recursion. If you don't have a terminating case, your recursive calls are never going to end. So I hope it's clear to every one of you. Just like loop, in a while loop, if you not terminate, like the condition is I less than 10 and I is equals to 1, you have to print I. If you are not incrementing the value of I, it will be an infinite loop. So just like the same way over here, we are having the Stack Overflow. Now the other question that might arise is like in while loop. And if I don't have this over here, the terminating statement, over here we get a Stack Overflow error. But why not here? Yes, this might be a doubt, because yesterday we have discussed about while loop and we didn't get any error. It was running infinitely, but we didn't get any error. Am I right? So the reason for this, what this is doing, it is executing task. It is not keeping the task at hold. Am I right? So what it has to do, it has to do print I, print I, print I, print I, check the condition, print I, check the condition, print I. It is not of storing the data, correct? It is just performing this task. But now what happens over here? It has to maintain a stack, because I will explain you the reason, do not worry. I am not having terminating statement, so this won't return us 1. It will go infinitely. Am I right? And so on. But over here I have to maintain the stack for this, because at the end if someone returns something, that I have to go in a reverse fashion and I have to return the actual output for this computation. So I have to maintain a stack for this. I have to hold this data. Am I right? I have to hold this call. I have to hold this call as well. I have to hold this call as well. As soon as someone returns, I have to just pop this results and I have to go up till my first result. So that's the reason why we get an error in recursion, because we have to maintain a stack for this. And we'll also see how stack works, the LIFO patterns. So do not worry about this. But yes, I hope you get a better understanding that how recursion and how recursive call works and what is the significance of terminating statement in recursion. So yes, it will be clear to all of you, and do practice it, otherwise you are going to forget it ASAP. So in our next lecture we are going to learn about let's take string. Yes, so in the next lecture we are going to take strings, and do not miss the lecture. It is really one of the very important part of Java, and many of the interview questions are there, and there are a lot of problems in strings as well. So it is very important to have a better, or I can say the best understanding of string concepts. So let's catch up tomorrow at the same time, 7:30, and thank you all for joining today's session. And if you have any doubts, you can post it in the comment section. All right, so thank you so much for joining today's session, and we'll meet tomorrow at the same time. Thank you.